Hello, in this video I'll talk about what happens when a capacitor unit kind of has a blown fuse. What happens to voltage? So, I'm just going to take a simple example here. I have 1, 2, 3, 4, 5, 6 capacitors that are in parallel and they are fused. Then I have another 6 at the bottom. They're also fused. So let's assume that the voltage applied across the capacitors is V. So if I had to draw this as an equivalent, so I can draw it something like this. When a capacitor is in parallel, they add up like a resistor is in series. So I'm just going to call it C. So I have 6, so 6C is in series with another 6C. So then you have V. So the voltage would be just 1/2 of V across each combination. 1/2 V. In other words, the 6C here will have 1/2 of that total voltage, and the other 6C will have total. Now let's assume this fuse was blown for whatever reason. So now this capacitor basically is gone. It's open circuited, so it does not exist. Now, so with blown fuse, so the equivalent would look something like this. So you still have applying the same voltage, but here you will have 5C, and here you will still have 6C. So I only lost one capacitor. Well, now let's call this voltage V1 and this voltage V2. So we want to know what those voltages are. So if we do voltage divider, V1 is just the total voltage V, and we know the impedance of a capacitor in general, it's 1/J omega C. So we'll use that. So the voltage divider, so V1, so it's 1/J omega 5C over 1/J omega 5C plus 1/J omega 6C. So V, so J omega C will go away. J omega C, J omega C, J omega C. So I end up with 1 divided by 5, total divided by 1/5 plus 1/6 equals V. Now I'm going to multiply up and down by 5. So I get 1 divided by 1 plus 5, 6. Because all I did is I multiplied top and bottom by 5. So now equal to V 1/6 plus 5, 11 divided by 6. In other words, 6 divided by 11 times V. So this is V1 is equal to 6 divided by 11 times V. So remember here, I started with 1/2 of V when I did not have a blown fuse. So if I want the difference, like what's the voltage change now? So 611 minus 1/2 is equal to, so 12 minus 11 divided by 22. So it is 1 divided by 22, which is, it's V here, 1/2 V times 1 V, the total voltage basically. So if you do the math, that comes to be 4.54%. In other words, the voltage increased by 4.54%. So you have an over voltage across the side, with the blown fuses. So now we can do the same thing for V2. So V2 is just, so we'll do the voltage divider. So V times 1 over J omega 6C divided by 1 over, J omega. So I'm just gonna write it here. Or actually, let me just use another page to be. So V2 is equal to V. So it's 1 over J omega 6C, because V2 is across the 6C. So 1 over J omega 6C plus 1 over J omega 5C. Again, it's just voltage divider. So I have J will go away. I have omega C will go away because I can cancel them out. I end up with V 1 over 6 divided by 1 over 6 plus 1 over 5. So I'll multiply both top and bottom by 6. So top will be just 1 plus 6 divided by 5. If I simplify it more, so I get 1 over, so 5 plus 6 is 11 divided by 5. So V2 is equal to V times 5 divided by 11. So that's V2. And remember, I started with 1/2 of V. So if I do 5/2 V, 5 divided by 11V minus 1/2 V. So I get 10 minus 11 minus 1 over. So it's minus 4.54%. So the voltage increased actually by 4.54%. So the voltage is lower. So V1, since it lost one capacitor unit, it increased by 4.5%. The other side, the healthy side that didn't lose any capacitor, actually the voltage was lower. So that's very important, So whenever a fuse is blown, you want to balance that voltage, So probably you want to remove, probably open this side here to kind of balance that voltage, So thank you and have a great day.